When you see 5 with an exclamation point after it, do you shout 5? No. Anybody remember what that means? Yeah, 5. This is called 5 factorial. 5 factorial. And it means 5 times 4 times 3 times 2 times 1, although you don't really need the 1 there. It doesn't do much. So what would n factorial be? N times n minus 1 times n minus 2. You could do this the rest of your life, but let's just go dot, dot, dot. Eventually you get to times 2 times 1. 0 factorial. This is a definition. It turns out that formulas, especially in counting formulas you'll see in probability classes if you ever take statistics, for instance, turns out the formulas work out nice if you define 0 factorial to be 1, and so we do. I know, it sounds weird. It's like, we're just saying that's true. And we're making it up, and it works.
And we don't know why?
Well, it just makes the formulas work out nicely if you want to plug in 0. That's why. But it's nice that it works. If you wanted to calculate something like 5 factorial, in your calculator, your calculator will do 5 factorial, it'll do 7 factorial, but if the numbers get too big, the calculator won't compute it. It's too big for even the calculator. You'll break your calculator. No, you won't break it, but it won't do it. It'll say error. So, but there is one way to do it. You could say 5 factorial over, okay, what's 7 factorial? 7 times 6 times. We could keep going, but why not make it 5 factorial? Do you see what will happen? Now, this only works because we have operations of multiplication in the numerator and denominator. But it cancels, right? 5 factorial, 5 times 4 times 3 times 2 times 1. Those will divide out with the factors in the bottom, 5 times 4 times 3 times 2 times 1. So you might as well just divide out the 5 factorials. What's left? 1 on top, and then 7 times 6 on the bottom, so 42.